So hello everyone, today I am going to talk about the sorting algorithm. Sorting is the process of arranging data in a particular order, usually ascending or descending. Sorting is important because it makes searching, organizing and analyzing data more efficient. So first, what is a sorting? So first, what is a sorting? Sorting means arranging data in a specific order. Okay, it used to reorder elements in a list or array. They are widely used in a computer science for tasks like organizing database, optimizing searches, and improving performance of other algorithms. There are different types of sorting algorithm, such as a bubble sort, selection sort, insertion sort, and merge sort. Today we will focus on all sorting. First bubble, then selection, insertion, and again merge sort. Okay, so first, ascending order means small to big. Okay, and descending order means big to small. Suppose we have a data like 1, 2 and 3, means this is in your ascending order, because first small to big, and big to small means opposite, 3, 2 and 1. Okay, so this is our descending order. Now, example, unsorted array is a 9316. Sorting in ascending means small to big, so there is a 1, 3, 6 and 9. Okay, so sorting helps to search data fast, arrange records properly, and improve performance. Okay, so types of a sorting technique. Below are the most commonly used sorting algorithm in data structure. First one is bubble sort. Bubble sort is like a water droplet. Okay, in a bubble sort, there is a comparison between two adjacent elements. If they are in wrong order, swap them. After each passes, largest element goes to the last. Okay. So now, steps. Here is the steps. You can see. Okay, compare between the array 0 and array 1. If they are in a wrong order, then swap. If they are in wrong order, then only swap, otherwise keep it as it is. Again, compare with array of a 1 into an array of a 2. If so, swap if needed, otherwise leave as it is. This process continue again and again until array is sorted. Okay, so time complexity of a bubble sort is best is O of n, worst is O of n square, and worst case here is not. Okay, so now C++ in C++ code of a bubble sort. In bubble sort, int array int n. Okay, so for loop, here is for loop. For int I equal to 0, I less than n minus 1 and I plus plus. For int j equal to 0, j is less than n minus I minus 1 and j plus plus. Here is a comparison between the array of a j and array of a j plus 1. If they are in wrong order, then you swap. Okay, otherwise leave as it is. Now, for example, you can see. Here you can see now step 0. This is a step 0. Okay, so so this is a step 0. 2 minutes. Okay, in step 0, I equal to 0 means minus 2, 45, 0, 11 and minus 9. This is our given array. So in a bubble sort, array of I, here is a comparison between, we see array of a 0 into array of a 1. Okay, so array of a 0 is a minus 2 and array of a 1 is a 45. The comparison between the minus 2 comparison between the -2 and 45. Okay, 2 minutes. Okay, here is a comparison between the -2 and 45. 45 is always greater than -2. Okay, so there is no need to swap if needed. Again, in an I equal to 1 for loop, a great increment होणार I equal to 1. In there is a comparison between the 45 and 0. Okay, 45 is a greater than 0, so swap them. There is a in if there is a wrong order, swap them. Okay, so again there is a swapping. Okay, 0 first, then again 45. Now comparison between the 45 and 11. Okay, 45 and 11. 45 is greater than 11, so there is a need to swap. Okay, so now in I equal to 3, swapping 11 and 45, and comparison between the 45 and -9. Everyone know 45 is greater than -9, so there is a need to swapping. Okay, so this is a step 0. Again a step 1, step 2, step 3. In first step, after each phase means each step, largest element goes to the last. Okay, so here is the largest element in all array is a 45 and it goes to the last. So again comparison until -9 in step 2. Again step 1, in step 2 comparison with in index number 3 and 2 and then 1. Okay, this one is a step 1. Okay, now step 1. In step 1, this process start means until this process repeat until the your all array are sorted. Okay, so in step 1, now this array -2 is comparison with 0. These are the correct order, there is no needed to swap. Again 0 is comparison to 11, there is no needed to swap. Again 11 is in comparison with -9. In comparison between the 11 and -9, 11 is always greater than -9, so there is a need to swapping. And there is no need to comparison between the 11 and 45, because 45 in first step largest element goes to the, here you can see your largest element goes to last after each passes. Okay, in second step, now 11 is our correct position. In step 2, -9 is our correct, 0 is our correct position, and again -9 and -2. Okay, so now next sort is a selection sort. In selection sort, there is a concept is to find the minimum element from unsorted part. Okay, put it at from a beginning. Selection part, there is a simple methodology like a select element. Okay, explain with the help of example. So there is a step, assume first element is a minimum, compare with all other elements, swap with actual minimum, repeat for next index. Okay, there's a time complexity based is O of n square and worst is O of n, O of n square. So here is a code of a selection sort. Here you can need minimum index and array minimum index. Okay, there is a code. Now how selection sort works. So in step 0, index number I equal to 0, minimum value at index 1. Okay, so याच्यामध्ये first there is a comparison between the 20 and 12. 10 is a minimum, means index number 1, 0 index, 1 index, 2 index, 3 and 4. So minimum index is 1. Again 12 is comparison with the 10. Now 10 is our uh, minimum element at index number 3, sorry 2, 0, 1 and 2. Again comparison between 10 and 15. Now our 10 is always less than 15. So minimum element is a 10 at index number 3, sorry 2. Again there is a 10, now minimum element is a 10. So comparison with the 2 and 10, comparison between 10 and 2, because 10 is less than 15. So now 2 is our less element, minimum value at index number 4, and 2 is a so now 2 at a first 0th index. Again this is our sorted part. Okay, and this is our unsorted part. Now again comparison between 12 and 10. 10 is a less, 10 is comparison with 15. 10 is always less. Again 10 and 20, 10 is less. So now 10 at index number 1, and then 12 now 10 is replaced with the 12 and 12 is replaced with the 10. Okay, सिलेक्शन सॉर्टमध्ये इन सिंपल सिलेक्शन सॉर्टमध्ये काय असतं, एलिमेंट जो की लार्जेस्ट स्मॉलेस्ट जो काही एलिमेंट असेल त्याला सिलेक्ट करायचा आणि ते त्याच्या पोझिशनला बसवतो. मग नाव आता आपला हे झाला, सॉर्टेड झाला. अगेन पुन्हा त्याच्यामध्ये दिस प्रोसेस अगेन अँड अगेन रिपीट अंटिल आपला अख्खा ॲरे जोपर्यंत सॉर्ट होत नाही तोपर्यंत आपण ती प्रोसेस रिपीट करणार. नंतर याच्यामध्ये पुन्हा स्मॉलेस्ट एलिमेंट बघणार आणि तो त्याच्या वन इंडेक्सला ठेवणार. पुन्हा राहिलेला एलिमेंट जेव्हा आपण हे करतो तेव्हा तो एलिमेंट हा आपला 2 जो की मिनिमम आहे तो 20 बरोबर काय होतो, रिप्लेस होतो. ओके, बिकॉज ऑफ द 2 मिनिमम व्हॅल्यू आहे आणि ती त्याच्या इंडेक्स नंबर 0ला जेव्हा प्लेस होते तेव्हा जो की 0मध्ये कोणताही एलिमेंट असो तो त्याच्यामध्ये काय होतो, तो रिप्लेस होतो. दिस इज ॲज इट इज सिम्पल सिलेक्शन सॉर्ट. नाऊ insertion sort. Insertion sort means insert an element. Okay, correct position or insert it into its correct position in the sorted part. Okay, start from second element. In insertion sort, there is a start with second element because of our first element. Let's consider as a sorted element. So start from a second element and compare with the previous element, shift elements and insert at correct position. There is a time complexity is O of n and worst is a O of n square. So here is the code. Avoid insertion sort, int array, int n, a for loop. If int key equal to array of I, int j, I minus 1, while loop, here is a condition, and array j plus 1. Okay, there is no need lyrics. So insertion sort, first element is considered as a sorted element. Okay, now 23 is a sorted and 1, 10, 5, 2 is a unsorted element. Now 23 is compare with 1. Okay, 23 compare with 1, 1 is always less than 23 is greater, so swap them. Again this is our sorted array and this is our unsorted part. Okay, now 23 is 10 is compared with the 1 and 23. 10 is less than 23 but greater than 1, so put in middle between the 1 and 23. Again, this is our sorted part, this is our unsorted part. Again, 5 is comparison with 1, 5 is greater than 1, again less than 10. So 5 is between the 1 and 10. Again, this is our sorted part, this is our unsorted part. Again, 2 is compared with the 2 is compared with 1, greater than 1 is 2 is greater than 1 and less than 5. So at index number 1. सो याच्यामध्ये काय असतं इन्सर्शन सॉर्टमध्ये आपला एक असतो सॉर्टेड एलिमेंट आणि एक असतो अनसॉर्टेड. याच्यामध्ये सॉर्टेड जो घेतलाय त्याला जे की बाकीचे अनसॉर्टेड एलिमेंटला एक एक एलिमेंट इन्सर्ट करत जायचं की सॉर्टेडमध्ये. 1 आपण फर्स्ट इथे 1 घेतलाय की ज्याच्यामध्ये 1ला 23 बरोबर कंपॅरिझन केलं त्याच्या देर इज अ नीड टू स्वॅपिंग. सो स्वॅप इट इफ देर इज अ नीड. Then again these two elements are sorted. Again 10, 5, 2 is comparison between the sorted part. If they are in correct order, so leave it, otherwise swap it. So now merge sort. Merge sort uses divide and conquer. Divide array into two halves, sort them individually and merge them. Okay, now time complexity of n log n and worst case is O of n log. Here is a simple C++ code. Okay. So here is a merge sort. If there is an array, first divided into half. Okay. Now there is a 38, 27 in one half and 43, 10 is a second half. Now 38 and 27 again divided into two half. So 38, 27, 43, 10, these are now separated. Then divide and conquer. Here is a step like a first divide and conquer, divided into two halves, sort them individually. Then sort 38 and 27. 27 is less than 38, so sort this array now sorted. And for then comparison between the 43 and 10. 10 is less than 43, so this array is a sort individually and this array is a sort individually. Now merge it. Then 10 and 27. 10 is less than 27 and 27 then 27 and 38. 27 is less than 38 and then 38 and 43. 38 less than 43. Now this is our sorted array. Now this is our sorted array. So in merge sorted, like a divide and conquer, sort individually and then merge it. Now quick sort. Quick sort concept, pick a pivot. In quick sort there is a pivot. Place pivot at a correct position, elements smaller left, elements bigger right, recursively sort left and right. Now here you can select pivot and then all elements compare with the pivot. Best case is O of n log n and worst case is O of n square. Okay. Here you can see this is our given array. You can select a pivot at first element and last element as you wish. Suppose there is here is a 3 is a pivot. Then now 3 is compared with all element. First 3 is compared with 9, minus 3, 5, 2, 6, 8, minus 6, 1. All elements compared with the 3. If elements are less than 3, they are occurring left side, and if elements are greater than 3, these are in right side. Okay. Now again there is a comparison between the minus 3 and minus 5. Sorry, here is you can see there is a minus 3 and minus 6. 1, 2, then 3, here 5, 6, 9 and 3. Okay. क्विक सॉर्टमध्ये काय असतं माहिती का, खूप साधं असतं की आपल्याला पायवट आपल्या स्टेपमध्ये आपल्याला काय करायचं असतं, पायवट सिलेक्ट करायचा असतो आणि पायवटमध्ये पायवट सिलेक्ट केलं ना आपण की त्याच्यामध्ये कंपॅरिझन केलं जातं. ओके. याच्यामध्ये पहिल्यांदा आपण 3 हा एक पायवट सिलेक्ट केला आणि त्याच्यानंतर आपण 3ला जे काही एलिमेंट आहेत 9, तो मोठा आहे 3 पेक्षा. सो आपण राईट साईडला पुट केला. -3 इज लेस दॅन 3 म्हणतो आपण राईटला केला. देन 5 इकडे, 2 इथे, 6 8 -6 आणि 1 3. आता आपल्याला दोन पार्ट झाले, एक लेस दॅन 3, एक ग्रेटर दॅन 3. ओके. सो आता लेस दॅन 3 मध्ये पुन्हा एक आपण काय केला, पार्ट सिलेक्ट केला 1, आणि ग्रेटर दॅन 3 मध्ये 6. देन 1 इज कम्पेअर विथ अदर एलिमेंट. सो 1 and -3 and -6 इज लेस दॅन 1, 2 इज ग्रेटर दॅन 1. सो याच्यामध्ये आपल्याला झालं की 1 पेक्षा लहान, लेस दॅन 1 आणि ग्रेटर दॅन 1 एलिमेंट्स गावले. इथं 6 मध्ये पुन्हा तेच झालं, लेस दॅन 6 एलिमेंट्स अँड ग्रेटर दॅन 6 एलिमेंट. अगेन -3 and -6 there is need to swap because of the you can select pivot is a -6 and -6. Then comparison between the -6 and -3. -3 is less than, greater than -6. Okay, there is a negative sign, that's why. Again, there is a no need to comparison. Here is a need to comparison. Select pivot is a 3, 8 sorry, and 8 is a it is less than 9. So there is means in quick sort you can select pivot and then compare with other element. Again, there is a 2 half. Okay, less than and greater than. Again you can select pivot and then compare with this process until your all arrays are sorted. Repeat this process until all sorted array. Here is the time complexity, bubble sort, a selection sort, insertion sort, merge sort, and quick sort. Which sorting is the best? Suppose you have a small data, or you go bubble sort and insertion sort. Large data means merge sort or quick sort. Fastest on average, quick sort. Most consistent, merge sort. That's it for today. Video आवडल्यास please like, share and subscribe. Thank you.